I-55.
Yeah.
Real close to Zora.
Okay, right now we're
Okay.
recording.
Yeah, well, this is an aspect of the St. Genevieve fault system, which is, it's by far the biggest fault system in Missouri and in the Midwest. It's it covers a large area of eastern Missouri and the eastern Ozarks. Covers a large part of St. Genevieve, Cape Girardeau counties, Perry County. Covers a big, and you go through it when you take I-55.
Yeah.
When you get around St. Genevieve and between St. Genevieve and Perryville, you see tilted beds, and you see a lot of different formations showing up that don't normally show up in much other part of the state.
Yeah.
And it also goes deep into below the crust. It actually tapped into the mantle because it has brought up kimberlites, and kimberlites are mantle materials, and which include, by the way, diamonds.
Yeah, we made a video about that.
We did a video on diamonds in Missouri, and they've not been found, but they could well be, and because there is kimberlite brought up to the surface on the St. Genevieve fault system, and that's below the crust. That's quite.
Wouldn't that be volcanic if it's kimberlites coming up somewhere?
Yeah, it was. There were volcanoes in the Paleozoic and the Devonian period.
In that area?
In that area, yeah.
That's where Elephant Rock came from?
No, not Elephant Rocks. Elephant Rocks are much older. No, the kimberlites are Devonian in age in Missouri. And they were brought up from the mantle during the Devonian period.
Is that the same Devonian that made the Arkansas diamonds?
No, the Arkansas kimberlites are younger. They're Cretaceous, late Mesozoic. But no, the kimberlites in Missouri are older. But they're associated with the period of great activity on the St. Genevieve fault system.
So the St. Genevieve fault system existed at the same time the Arkansas diamonds were being formed?
Yes,
And the ones here in Missouri?
Yeah. And the St. Genevieve kimberlites were brought up much earlier than the Arkansas kimberlites.
I see.
There's that one, Commerce. Commerce is not too far from Benton. That road that goes to Benton. Benton is where the power works.
Boomtown.
Boomland. And then that road that goes east from there, it goes over to Commerce. And there's bedrock on both sides of the river, which means that's been active geologically recently. It's active recently enough to where the river erosion has not been able to remove the bedrock. And that's what this.
And how is that similar to or tie in with Cape Girardeau?
Well, it's the geology, same geology as around Zora. And on the south side of the fault, on the north side is the geology of Jefferson County and St. Louis County, and they're both totally different. They're both totally different geologies.
You wouldn't expect that. Is what you're saying.
No, on one side there's about, I guess, 2,000 feet or almost of Silurian and Devonian strata. That's the south side of the fault. And the north side, there's none. Except there's Upper Devonian, which is the only Devonian in Jefferson and St. Louis counties. And that's on the north side of the fault. But the weird thing is, the south side includes the Bailey Formation, which is a Devonian, a slower Devonian, extremely cherty, full of flint. It's probably the chertiest, flintiest rock in Missouri. And that's really saying something, because Missouri. Okay. On the south side, there's Bailey Chert, and it's Bailey Chert and limestone, Bailey Formation, and it's probably 500 feet or 400 feet of rock. It's extremely cherty, when it weathers, now here's the thing that's weird. When the Bailey weathers, the chert is left behind as a residue. It's called residual chert.
Yeah.
And it's all over Missouri. I mean, but the Bailey Formation is the chertiest of the cherty Missouri
Cherty
rocks.
chert, yeah.
Really, really super cherty. And chert doesn't weather very. It sticks around. It's quartz.
Yeah, yeah.
It sticks around. On the south side, there's Bailey chert where it's weathered, and there's where the Bailey outcrops. There's lots of Bailey chert, and Bailey chert sticks around. It's flinty. It's hard. It's very, very resistant to weathering, and it sticks around for millions of years. On the north side of the fault at Ozora, there is absolutely not only no Bailey Formation, but there's no Bailey chert.
Yeah.
But on the south side, there's a huge amount of it. And it's like two geologies. And the only way that you can take a formation like the Bailey, that's a continuous layer of rock covering a big area, is to take a little piece of that and move it somewhere else. And that does happen with plate tectonics. That's how plate tectonics really was discovered. That they found geology of one area
slid to another,
like glued to another, right? And that's what you have on the St. Genevieve fault. You have two geologies. On the south side, you have the geology of all this Silurian and Devonian rock. On the north side, you have none of that, none of it at all. You have the geology of Jefferson and St. Louis counties, and if there hasn't been movement of part of the earth, either part of Jefferson and our St. Louis counties moved in juxtaposition to the geology of around Grand Gulf area, or rather Grand Tower area along the Mississippi River, then there's no other way to explain it. And that means that part of Missouri had to have been moved 30, 40, 50 miles. And that's, in a continental geology, that doesn't normally happen. And
could it have gotten thrown there by an underground explosion, blew it plate out?
Now, there'd be fracturing, and there'd be all kinds of tectonic evidence or something like that. Yeah. It's weird. It's really, other than explainable by some sort of horizontal thrusting, what is called a thrust fault, a very low angle thrust fault, where that thrusting took place for 30, 40, 50 miles. There's no way to explain that.
But there's nothing to source the pushing it there.
No, nothing that you can see. No.
So it's just out.
It's not mentioned. Geologists don't mention it because it can't be explained.
Yeah, that happens a lot. They don't want. If you can't explain it, then they don't even want to approach it.
Ignore it.
Yeah.
Yeah.
But you should ask as many questions as you can, I would figure.
And I know of no explanation I've ever heard for it. And it's the geology is weird enough that the University of Chicago had a geology field camp down there in the 1920s.
Trying to figure out what was going on.
Well, using it to teach students to be really good field geologists. Yeah. Because it's
it
really challenging field area. The area's heavily covered with vegetation. And there's pretty many outcrops, but it's not like out in the western United States where you have
right there in the open,
that are real easy to figure out what's going on.
Yeah.
In Missouri, you have to do some sleuthing to figure out what's going on.
Yeah, you would.
Miracles or what have you. I mean, science ignores those. And art tries to explain them in some rational way. And I don't know if I presume the rational explanation of the Ozora area is that it's thrust fault.
Yeah.
But I've never actually heard that from in my geologic background. Which, and by the way, I have 3 degrees in geology. I have, including a PhD from Rolla. I have a pretty kind of tough and extensive geologic background.
Well, most of your viewers know that about you already.